Welcome back to the show floor here at Helitech International. I'm thrilled to be having a chat right now. It's going to be a fascinating conversation with Paul Taylor from ECS. Hi, Paul. How are you doing?
Good morning. Thank you very much.
Right. So, tell me, first of all, about Enterprise Control Systems.
So Enterprise Control Systems is a small company in the UK, about 50 employees, based in Northamptonshire. And we really have two main product lines, one of which is to produce surveillance data links, that is to downlink full motion video from many of the aircraft in this hall, from their high-end surveillance camera systems, and we provide the data link to the ground to distribute that imagery for police users, for military users. And we do that in about 40 countries of the world. A second part of our work is to produce RF inhibition systems, which are very military, not being shown here, to stop remote-controlled improvised explosive devices. But what we have done is combined both of those pieces of technology into a new aspect that we're showing here, which is the anti-UAV defense system called auds. Because, as you are aware, the increasing number of unmanned air vehicles, particularly the small commercial ones, are about 2 million in the world. Some of those are now starting to be used for malicious purposes. So for every good aspect or use for surveillance, there's a bad person using them as well. And they are starting to appear as threats, not on the military battle space, it's for surveillance, for border security incidents, for intrusions into critical national infrastructure, and indeed for flight safety alongside aircraft or aircraft positions. And maybe relevant to a lot of people in this room, helicopters being used for firefighting purposes are often having to be taken out of the skies because enthusiastic amateurs are flying their UAVs to have a look at where the fire lines are. So we have a malicious use of UAVs, and we, along with two other companies, got together a year ago to produce a system to defeat those UAVs whilst they're in the air. It's not a kinetic effect. We attack the command and control links, so effectively it's a jamming technique to encourage the operator to fly it back to the launch location or to have the autopilot on board return the UAV to its home location. All of that time it is being under surveillance on a camera system, it is under surveillance under a radar system, so we're effectively detecting those intrusions of small UAVs, small handheld ones, at ranges of up to 8 kilometers by radar. We can see them at about 4 kilometers away on camera systems, and then we can carry out an RF inhibition technique when those reach 2 kilometers from us. So anything within 2 kilometers we can actually impact. The intent being to either force the UAV to land on the ground, go into a controlled landing, or better still, really to return to its operator. That gives somebody in the security operation the chance to go and interview the operator.
Yeah, so you can find out where the operator is and have a serious word with them. Now, this device that you're talking about, that's what's over my shoulder here, isn't it?
It is indeed.
It looks seriously impressive. I have to say, it looks as though it's probably a little bit more attacking than what we just discussed here. It looks quite like a battleship machine gun, I'm not going to lie. What are you allowed to talk about in terms of what these various bits on it are?
I can describe pretty much all of it to you. So what I would say is you're looking at half of the hardware here. There is another piece of hardware which is the radar system, which we don't have on display, which is doing the detection. But then, if you like, this is the business end. So in the center of that device is a servo-controlled positioner, which actually points the entire camera turret and the RF inhibitor in the right direction. As we're looking at it at the moment, the left-hand side you can see the electro-optics or the camera system. And within there is a high-definition daylight color TV camera. There is also a third-generation thermal imager for thermal views. And that camera system not only enables you to see the UAV, but it also locks on automatically and tracks it automatically through the sky. So the operator is not having to steer the camera in the right direction.
Now, what is it that stops one of these UAVs that you're tracking and jamming from just falling to the ground? You must have some intelligence on how the UAVs themselves work in order then to control them.
Indeed we do, and that brings me neatly on to look at the right-hand side of the payload up there, the more aggressive parts, if you like.
Let's wander over here. Right, okay, so This bit here.
So the more aggressive parts on this side here consist of the electronics unit for the jammers, and then the three very obvious tubes are actually 4 antennas. I know there's only 3, but there are actually 4 radio frequency antennas in there. And so the way we have an impact on the UAVs is that all of those commercial UAVs use unlicensed frequency spectrum deliberately to operate. Those are frequencies which are regulated globally, of which all the manufacturers design. There are a limited number of them, and those 4 antennas there enable us to put RF energy into those bands. We deliberately use directional antennas, so we focus the effect onto the UAV, and that's why it's important to be able to point at it.
Is that what we're seeing in the background right now?
Yes, you can see on the background that video of some sort of training and demonstration footage taken. It's simulating the jamming activity. Very difficult, of course, to demonstrate it because jamming in the RF environment is very controlled by the frequency regulators. But the system has been tested by the French government, by the British government, and in fact by the US government. It's looking at non-kinetic solutions to UAVs. So by putting some jamming into the command and control link, we're effectively denying the operator control, and the operator's going to say, there is something wrong with my UAV that I've just paid X amount of money from. We will then remove the jamming effect and enable him to take control again, and he'll fly it home, or the autopilot will fly it home, or alternatively, depending on the design of the UAV, and of course there are many hundreds of different types of UAV, their autopilots will cause them to do a controlled landing, or some of them, particularly if we interrupt the navigation signals on them, may become unstable and then head towards the ground. So again, it's important why there's a camera system there, so that the operator can see the effect that he's having with the jammer. So the whole 3 parts are: detect it's there with a radar, confirm it on a camera, make sure it's not one of your UAVs, identify whether it's being used for a hostile act, and then go into the disruption phase to do something about it. So it's a completely integrated system put together by 3 UK companies. ECS, doing the RF inhibitor, happens to be here at Helitech, so we're sort of delighted to be able to present it for everybody to see.
And thank you so much for chatting us through that in great but fascinating detail, and indeed for bringing this head unit here. It looks amazing, I have to say. Now, I've got voices in my ear that are fascinated by this. They're all kind of drone owners or drone flyers, or people fascinated by the whole kind of RF angle of this and transmitting data up there. The other angle of your business that we talked about right at the beginning of this interview was about secure communications from an airborne vehicle back to ground, particularly for surveillance purposes. Just in a couple of minutes, just chat us through a little bit more about the kind of technology, the kind of ranges and the kind of uses for that.
Okay. So certainly, so the surveillance data links really designed for the high-end surveillance users, often using rotary aircraft, but also using small fixed-wing assets these days. Those users will typically have a high-end camera system on them, and we then move the images to the ground. So through that pipe, we'll downlink simultaneously 2 high-definition television images, and also some GPS position data and other mission data from the aircraft. Equally, we can send images back up to an aircraft that is actually controlling surveillance tasks, and importantly with the ECS even load system of equipment, as we also provide an IP link between the ground and the aircraft. So effectively the user can have his internet in the sky, or more importantly access to mission critical data which may be sitting on databases on the ground, that it doesn't have to be uploaded onto the aircraft. So it allows for rapid retasking of aircraft in mission, so they can access sensitive data. Now, the sort of ranges we get out of our system, designed specifically to be secure and long range, is when we're around the sort of 2.4 gigahertz. 150 to 200 kilometers, it's a line of sight range from the ground to the aircraft. Now, we also install metropolitan area networks of all the receivers where there might be multiple receive sites and multiple aircraft systems in the air. So Enterprise Control Systems has also contributed significantly to the UK NPAS program in terms of ADL, and obviously to the UK military. and also to about 40 other countries around the world. There'll be people like the Gendarmerie Nationale in France, including their special forces, KLPD in the Netherlands. So there's a very niche tech and specialist technology which we provide the pipe to integrate a lot of the mission systems, whether they be cameras or mapping or data.
And this is a secure pipe. It goes without saying, nicely encrypted, I'm sure. What sort of bandwidth do you get? Sorry, we're going very much into tech talk here, but I don't care. This is fascinating stuff for a geek like me. What sort of bandwidth do you get? And just talk me through very quickly the kind of encryption that you use.
So the on-air bandwidth we're normally using is 8 megahertz on-air bandwidth, but effectively we're producing a 20 megabits per second pipe from air to ground, and we can carve up that pipe, if you like, into a video component or into an IP data component, and that is configurable dynamically even during the mission. So if you certainly needed to prioritize movement of large amounts of data, you could actually squeeze down your video feeds, if you like, and increase your data feeds. The encryption, we have a proprietary encryption technique that we can release to anybody globally. But then we also provide AES 256 encryption. It's for those customers who are unable to receive that. It's under exploit compliance. So that tends to be the higher end government users.
Well, listen, Paul, this has been a fascinating 5 minutes chatting with you. Obviously, we're helicopter-centric at Helitech International, but to be able to talk about the UAV angle as well, not just flying them, but actually being aware of them. It's front page news every week, every month we're seeing this stuff. Thank you so much for sharing that with us. If people want to find out more about what ECS does, where can they go?
Well, obviously, please visit our website. It's enterprisecontrol.co.uk. Visit us here on the booth here at Helitech. It's delighted to talk with anybody, and thank you very much for giving me the opportunity to speak with you.
Paul, thank you very much. Brilliant. Paul Taylor from ECS.